In the first part of 4.9, we looked at just simply graphing inequalities with quadratic equations. Now we're going to be looking at taking that into systems. Now, if you remember back when we did systems of linear inequalities, we looked for where the shading overlapped. So we're still doing the same thing, but now with parabolas instead of just lines. So I'm going to graph each of these separately. I'm going to do them in two different colors so that we can keep track of everything. So I have a vertex form. Notice that k is 0, so my vertex is 2, 0. And if I plug in 0 for x, to find my y-intercept, I have 0 minus 2, negative 2. Squared is 4 times 2 is 8. So my y-intercept is at 0, 8. And I'm going to mirror that point. It is, y is greater than or equal, so I've got a solid, well, we're going to pretend that that's a nice smooth parabola. It's hard to do on here. Okay, so now the question is, where do I shade? So y is greater than, so that means I'm going to shade above, which is going to be inside my parabola here. Okay, so now when I do my second one, I'm going to look for where does the orange and green overlap. So this one, my vertex is 2, 3. Okay, and if I plug in 0, I get negative 2 squared, which is 4, with a negative in front. So negative 4 plus 3 is negative 1. So my y-intercept is 0, negative 1. And if I mirror that point, I get another one over here. And then I have less than or equal, so it's going to be another smooth. We're going to pretend that that's a nice smooth curve. And it asks for y is less than, so that's underneath the parabola, which is inside again. And notice the overlap is actually going to happen in this little space right here. So if I wanted to give an example of a point that satisfies both these inequalities, since these are solid curves, anything that is within, that borders this dark double shaded region would suffice. So 2, 0 or 2, 3 would work. So would, let's say, 2, 2, which is right about here. 2, 2 would be an example of a point that satisfies both of these inequalities. And if I'm not sure by looking at the picture, you can plug the points that you're choosing into both of the inequalities and make sure it makes both of them true. Okay, for the second one, I'm going to just reorder this one so it looks more like what we're used to. So I have y is less than negative x squared plus 4. Notice the b value is missing. So if I want to graph this one, the vertex is negative b over 2a, so that's 0. For b, so 0 over 2 times negative 1 is 0. And if I plug that in, I get 0, 4. Now what I notice is usually I use the vertex and the y-intercept, but in this case the vertex and the y-intercept are one and the same. So I'm just going to pick another x value to plug in. So I'm going to choose 1. If I plug in 1 to the equation, or the inequality here, I get negative of the quantity 1 squared. So I've got 1 squared is 1 with a negative is negative 1 plus 4 is 3. So I have 1, 3, which if I mirror that gives me negative 1, 3. It's a strictly less than, so I'm going to have dotted line. Okay, now if I want to shade that, it's below, so it's going to be all the values underneath. And let's do the next one in black. So now same idea here. My vertex again is going to be at 0. So it's the y-intercept. So I have to pick another x value. So I'm going to choose x equals 1. If I plug in 1, I get 1 squared is 1 minus 5 is negative 4. So I've got 1, negative 4. And I'm going to mirror that point. And again, it's strictly greater than. So again, dotted. And I want everything bigger. So it looks to me like the overlap is going to be here. Okay, so again, if I said, give me a point that satisfies both of these inequalities, a simple one would be the point 0, 0. But there's lots of points within here. Anything that's within here would satisfy. Nothing on the actual curves, though, since they are dotted, would suffice. Okay, I'm going to do one more of these. I'm going to do example C. Okay, so for C, that one's in standard form, so my vertex is negative b over 2a. So negative b is negative 2 over 2 times 1, so that's going to give me negative 2 over 2. So that's negative 1. If I plug in negative 1, I get 1 minus 2, which is negative 1 plus 1 is 0. So I've got negative 1, comma 0, and then if I plug in 0, I get out 1. I'm going to mirror that point. It is, it is less than or equal to, so it's going to be a nice, smooth, solid curve. And all the values less than or below the curve, so I have everything outside here. Okay, and then for the second one, I've got my vertex is 2, 3. And my y-intercept is, let's see, 4 squared plus 3 is 7. So I'm going to go 1, 2, 1, 2. And it is dotted because it's not or equal to. And it's all the values bigger. So again, that's the stuff that's inside of it. So it looks like my overlap is this space right here. So any of the points that are along the curve right here, the black curve, those would be solutions, but not the orange because the orange is dotted.